Okay, in this problem, we're going to basically work with this problem involving a wheel of a bicycle. A lot of moving parts here. We have the wheel, it's being pushed up by the ground, it's rolling along at a constant speed. The chain on the top and bottom are trying to turn the wheel. The radius of the wheel is RW. The radius of the cassette or sprocket is RC. Cassette and sprocket are the same thing. The bicycle frame itself, see the blue thing there is the back of the bicycle frame, will be pushing on the wheel. The first thing we want to do is draw a free body diagram of the wheel. So we'll draw a free body diagram of the wheel. Okay, so I have a normal force up, force normal from the ground, pushes up on me. I've got two tension forces that are pulling, so T1, T2. I'm also going to have a friction force from the ground, force friction. And the friction force is forward. How do I know the friction force is forward? Well, the bicycle is moving at constant speed and there's drag holding the right or backward. So to balance out the drag, you need to have a forward friction force. I mean, friction is what propels the bicycle forward. Okay, so those are those forces, but we need one more force. We clearly need one more force because these aren't balanced and the wheel is climbing at constant speed, so the force needs to be balanced. Sum of forces must be 0. We have a big force down here. I'm going to call this force bicycle. This is the force from the frame, from the blue frame, pushing back on the axis. Makes sense because that means that the wheel pushes the opposite direction on the frame, aka it holds the frame up and pushes it forward. Okay, so that's question number 1. Question number 2 is whether tension 1 or tension 2 is bigger. Okay, you can't answer this based on the free body diagram because tension 1, tension 2, and friction are all pushing forward. We don't know how big any of them are. We also have force of bicycle pushing backward. So we have a whole bunch of forces in the horizontal direction, and we can't solve for any of them just using the free body diagram. However, we can do sum of torques. So if this is our wheel, remember that it's going at a constant speed. I said that in the problem. So the wheel is rotating at constant omega. Omega is constant. That means alpha, the angular acceleration wheel, is 0, which means the sum of the torques on the wheel is 0. Okay, so let's write out the torques. Well, let's see each force and see if it creates a torque. Okay, force normal. Force normal pushes up on the bottom of the wheel. It creates no torque because it goes right through the axis. So it doesn't have any lever arm. The bicycle pushes directly back on the axis. So it doesn't create any net torque about the axis of the wheel. But the other forces, make my wheel a little bit rounder. The bicycle wouldn't roll very well. So the other forces are T1, T2, and friction, force friction. So each of those forces creates a torque. T1 tries to spin it this way. T2 and force friction try to spin it that way. It's going to spin at a constant speed. So the torque created by T1 has to cancel out the torques created by T2 and friction. So T1 must be bigger than T2. It has to balance out those other two. Then it brings us to the third question: how much bigger? 3. How much bigger should or is the tension 1 than tension 2? So here we'll just numerically do the sum of torques. Okay, so let's call today I'm going to call this the positive direction just because that's forward for the bicycle and this is negative. This is backward the way I usually do it. I usually do it the other way around, but I think forward should be forward for the bicycle today, so I'm going to pick that as forward. Okay, so the forward torque is T1 and then the radius of the cassette, RC. The backward torques are minus force friction times radius of the wheel, and a minus T2 radius of the cassette. And the sum of those torques is 0. We are told to find the difference between the two torques, so we're trying to find T1 minus T2. So I'm going to move this term to the other side, and I'm going to get T1 minus T2 quantity times RC is equal to force friction R wheel. Solving for T1 minus T2, T1 minus T2 is equal to force of friction RW over R cassette. Those are R's. Okay, and that is the answer. That's the answer there, that's the answer there, and that's our free body diagram. Let's just check the answer to number 3, make sure it makes sense. Units make sense because the difference in tension is a force. So units, newtons, meters, the meter from the two radiuses cancel, and so we just get newtons equals newtons. That's great. We can also notice that if RW is bigger than RC, which it is, right? The wheel is bigger than the cassette. The difference in tensions is bigger than the frictional force. Basically, this is your gear ratio, kind of like caused by the difference between the cassette radius and the wheel radius. You'll have the difference in the tensions will have to push harder than friction because it has a smaller lever arm. Okay, that's how you solve that problem.